sub question under that. Find GOF and FOG if f of x is equal to mod of x and g of x is equal to mod of 5x minus 2. Okay, so we have to find out what is GOF and FOG. So very simple, we'll start with the solution here. So solution. So what is GOF written as? GOF can be written as G of f of x. Understood? Similarly, FOG can be written as what? So here we'll write FOG can be written as f of g of x. This is GOF and this is FOG. We'll see what is, so g is coming here first, right? See here, g of f of x. So we'll see what is g of x first. So g of x is nothing but g of x. What is g of x, students? Mod of 5x minus 2. Now understand, inside the bracket here, okay, we have written x. That is the reason we are writing x here as well. Now what should we find out? G of f of x. Now instead of this x, what should we write, students? F of x. So write g of f of x, which is equal to, now in the place of x what we have written here? F of x we have written. So in this place of x what should we write? Yes, that is right, f of x. So here we'll write mod of 5 f of x minus 2. Understood? So now what is f of x? So for f of x again you have to see here. What is f of x? Mod of x. So we can write g of f of x is equal to 5 mod of 5 mod x minus 2. This is your right answer. So what is this, students? This is nothing but GOF. Okay. Moving on to the next one. Now we will find out what is f of g. Okay, we'll just change the color here. To find out f of g again, what? Same thing, students. We'll write f of x first. So what is f of x? F of x is nothing but mod of x. Why are we writing x here? Because we have written x here as well. Now in the place of x, what should we find out? Or in the place of x, what should we write? G of x. So write f of g of x, which is equal to, so in the place of x, so here we wrote x, right? That is the reason we wrote x here as well. Now in the place of x, what do we have? G of x. So here what should we write? Mod of g of x. What is g of x, students? G of x is nothing but mod of 5x minus 2. So therefore f of g of x will be equal to mod of 5x minus 2. So this is nothing but what? So mod of 5x minus 2 only. So which is nothing but FOG, and this is your right answer. Moving on to the next question. Exercise 1.3 only. Fifth question, second sub question. State with reasons whether the following functions have inverse. Okay, and the function is given g, domain and codomain. Okay, with g is equal to 5, 4. So we'll just try to map this once. Okay, we'll be getting the answer very easily. Okay, so here we'll start with the solution. 5, 4, 6, 3, 7, 4, 8, 2. So here we'll write the domain or the x elements 5, 6, 7, 8. And here we'll write the codomain. So that is nothing but 1, 2, 3 and 4. We'll try to map now, students. 5 to 4, 6 to 3, correct? So this is 5 to 4, 6 to 3, 7 to 4 again, 7 to 4 and 8 to 2. By looking at the mapping now, students, okay, this is which type of function? Okay, so just see this. All the elements of x are occupied, means all the elements of x have at least one image in y. Do they have unique images in y? No, because you see this 5 and 7 have the same image 4. So this cannot be 1, 1. So this function is not 1, 1. Why it is not 1, 1? Because all the elements of x do not have unique images in y. Example, 5 and 7, both of these elements have the same image called as 4. So that is the reason it is not 1, 1. Okay. Next, then which type of function is this? This is called as what? Many one. So it is a many one function. Is this an onto function? Okay, it is also not onto function. So what should we find out here? State with reasons whether the following functions have inverse. So we can tell that the function does not have inverse. Full stop. Have inverse, then so state with reasons. So what is the reason here, students? What is the reason? Because it is not 1, 1. That is the reason. It is not 1, 1. Therefore, it is not what, students? The function does not have any inverse. Moving on to the next question, students. Okay. Same exercise 1.3, question number 5. State with reason whether the following function have inverse h such that this set to this set with h is also given like this. So we have to tell that whether this function is having an inverse or not. Alright, so we'll just try to map them. So solution, students. So input values are the set of x values. So what do we have here? 2, 3, 4, 5. Correct. On this side what do we have? 7, 9, 11, 13. Now try to map them according to whatever the function is given, students. So if you try to map them, so 2 to 7 like this, okay, arrow diagram, 3 to 9, 4 to 11 and 5 to 13. So by looking at this mapping, what can we tell, students? Yeah. So all the elements of x have unique images in y, is that correct? So just see that, yes, it is correct. So therefore it is 1, 1 function. Is it many one function, students? Any two images, pre-images in x have the same y value or the same image? No. So it is not many one. Okay, as well as you see on the left hand, right hand side, all the elements of y are occupied, means all the elements of y have pre-images, correct? So therefore we can also tell it is a onto function. So previously what happened? It was not 1, 1, it was also not onto, so therefore the inverse did not exist. But in this case, it is 1, 1, it is also onto. So if the function is both 1, 1 and onto, what can we tell? So state with reason whether the following function have inverse. Yes. The answer is yes. The following function has an inverse. What is the reason? What is the reason? The reason is very simple, because the function is satisfying both 1, 1 and onto, therefore the function is having an inverse. So this is the right answer. Okay. Moving on to the next one, question number 8 of exercise 1.3 only. So consider f such that r plus is written, means set of real numbers which are positive or which are non-negative. Okay. Closed interval 4 comma open interval infinity of open interval, means 4 is included and it is going until infinity. So where it is stopping we don't know, but it's starting from 4. Okay, given by f of x is given here. F of x is equal to x square plus 4. Show that f is invertible. So we have to prove this. Show that f is invertible with f inverse of y is equal to root of y minus 4, where r plus is the set of all non-negative real numbers. So we should show that it is invertible, and also we have to show this. Okay, we'll start with the solution, students. So solution. So any function to be invertible, it must satisfy what and all? It must satisfy 1, 1, and it also must satisfy onto. So let us start with 1, 1. So how to start with 1, 1, students? Okay, as discussed earlier, write f of x1 equals f of x2. So once you write f of x1 is equal to f of x2, what can be written next? So in the place of x we have here x only, so we are writing x square plus 4. Now we are writing x1 in the place of x, right? So this can be written as x1 square plus 4 is equal to x2 square plus 4, x2 square, x1 square. Plus 4 and plus 4 will get cancelled. There is a equal to symbol in between. So we'll be getting what, students? x1 square equals x2 square. So this also can be written as x1 equals x2 or x1 equals minus of x2. So can we discard this? Why? Because see this here. set of positive real numbers, so this gets discarded because it is having a negative symbol here. So here only we are considering set of positive numbers. So therefore what can we write? x1 equals x2, which means the given function is 1, 1. So 1, 1 is satisfying for the given function. So now we'll also check whether onto is satisfying for this. If that satisfies, then it is invertible. Okay, then we can carry on further again. So let's start with onto here. So start with onto function. So how do we start with onto? Y is equal to f of x. So here, if you write y is equal to f of x, okay, what is x? What is f of x? X square plus 4. So we'll write y is equal to x square plus 4. Send the 4 that side. So x will become equal to plus or minus root of y minus 4. Again, there are two symbols here, plus and minus, and we are only concentrating on plus. So therefore minus gets discarded. Therefore x is equal to what, students? X is equal to root of y minus 4. So see this f inverse of y, that is nothing but x, is equal to root of y minus 4. So that is proved. Now we have to prove that it is an onto function. So how do we prove that it is an onto function? So what do we know? F of x equals y, correct? And what is f of x? F of x is nothing but equal to x square plus 4. Now what is x, students? X is nothing but this, root of y minus 4. So f of x can be written as, in the place of x, root y, in the place of x, write root of y minus 4. So root of y minus 4 the whole square plus 4. Square and root will get cancelled. Therefore f of x will be equal to y minus 4 plus 4. Plus 4 and minus 4 will get cancelled. Therefore what are we getting? F of x is equal to y, which means it is an onto function. So this function f of x is 1, 1 function, we proved. F of x is onto function also, we proved. And we also show that f inverse of y is equal to root of y minus 4, that is also done. Therefore what can we tell? This function is satisfying 1, 1. This function is also satisfying onto, which means the function is invertible. Understood? So any doubts, any of the problems here, please do comment in the comment section. Okay, we'll be solving that again. Okay, moving on to the next question, students. So this is the last pair of questions from exercise 1.3. Okay, next we'll be starting with exercise 1.4. So MCQs both are 13 and 14. So if f such that r to r be given, f of x is given, students, 3 minus x cube whole to the power of 1 by 3, then f of x is what they are asking. So is dash, okay, and they have given you 4 options. So first let us see what is f of x. What is f of x, students? F of x is nothing but 3 minus x cube whole to the power of 1 by 3. Now what should we find out? We have to find out this, right? F of x can be written as what? F of x can be written as f of x, which is equal to, in the place of x we have written x, so that is why we have written x here as well. Now in this place of x, what are we writing? We are writing f of x again. What is f of x? This is f of x. Now how do we write this? So this will become 3 minus, in the place of x we are writing what? F of x. F of x whole to the power of 3 whole to the power of 1 by 3. Now what is f of x? Substitute directly, that's it. So which is equal to 3 minus x cube whole to the power of 1 by 3 into 3. Now students, see this. This 3 and this 3, okay, this 3 is this one only. Apart from that, whatever is f of x, so this much is f of x. This bracket is f of x. So I think you can see that. Whole to the power of 1 by 3. Okay. Now see here, what will get cancelled out? This and this will get cancelled out. So what do we have now? Which is equal to, distribute this minus sign inside. It will become 3 minus 3, minus into minus is plus. It will become x cube whole to the power of 1 by 3. Plus 3 and minus 3 will get cancelled. What is remaining? X cube to the power of 1 by 3. So this 3 and this 3 also will get cancelled. What is? F of x. This will be equal to x, and this is your right answer. Understood? So which option, students? That is option C. This will be your right answer. Okay, moving on to the next question, number 14. So here they have given f such that r, so what are we leaving here, students? Minus 4 by 3 we are eliminating, or we are not considering. To r be a function defined as f of x is equal to 4x by 3x plus 4. The inverse of function is map g such that range of f to r minus, so we are eliminating this again from the set of real numbers given by. So basically they are asking what? The inverse of the function. Okay, they are asking. Alright, so how do we find out the inverse of the function again? So directly find out, students. So f of x is equal to, so y, we know that y is equal to f of x. Correct? And what is f of x? Y equals, f of x is nothing but 4x by 3x plus 4. Cross multiply. So y of 3x plus 4 is equal to 4x. So this will become 3x plus y plus 4y is equal to 4x. So this again can be written as 3xy minus 4x is equal to minus 4y. So sending 4x this side and 4y that side. So we'll take x common here. So if you take out x, what is remaining? 3y minus 4 is equal to minus 4y. So what is x equals to, students? X will be equal to minus 4y by 3y minus 4. So now take out the minus sign common in the denominator. It will become minus 4y by minus of 4 minus 3y. So minus and minus will get cancelled. So what is remaining now, students, here? 4y by 4 minus 3y. So that is nothing but option B. Okay. So that is nothing but what, students? Inverse of f. Understood? So this is the end of the questions. And also this is the end of exercise 1.3. We'll be starting with exercise 1.4.